What is going on, guys? Today I'm going to be talking to you guys about NAND gates. Now, NAND gates are basically the complement of an AND gate. So if you recall, this is what an AND gate looks like. We have one input, two inputs, and we have an output. Now, what an NAND gate does is it goes ahead and includes an inverter. So we have A right here, B, two inputs, and we have our inverter, our NOT gate here. If you remember or recall from the very first video in this series, what this basically does, correct? What this does for us is inverts the value of whatever is coming through it. So in our case, we have AB, and at this point right here, it's going to give us the value of AB, A and B. Remember, this is what the AND symbol looks like. Looks like a multiplication sign, or we can just label it this way. And after it passes through this NOT gate, we're going to have A, B, NOT. So we're going to have NOT A, B. So that is the gist of that. And this is basically our NAND gate right here. And what I want to tell you is this. When you represent these gates, the NAND gate, you are not going to write it that way. Instead, here's how you're going to represent it. The symbol for this essentially is you're going to have two inputs, the AND gate, and you are going to have an inversion bubble right there. So this is the same thing, the exact same thing, but it's just a much cleaner way of writing it. Now I'm going to go ahead and draw the truth table for these. I have A, B, Y, and I'm going to list out all the possible values of A, 0, 0, 0, 1, 1, 0, 1, 1. Now, remember, a NAND gate is basically the inversion or complement of an AND gate. So if you recall, A and B, if this were a regular AND gate, AB, if A were 0, B were 0, this would give us a value of 0. However, with the inversion bubble right here, we're going to invert that value, so 0 would become 1 and 1 would become 0, vice versa. Now, as I've mentioned, 0, 0 gives us the value of 0 when we AND it, and when we invert it, it's going to give us the value of 1. Now in this case, if we get 0 in any of these values, if 0 and 1, as long as there's a 0 in one of these inputs, we're going to get a result of 0. Now, because of this inversion bubble, we are once again going to invert that to a 1. Now, same goes for this one. 1, 0. We go through the circuit, we invert the value, and we're going to get the value of 1. Lastly, we have the value 1, 1. Now, if both values are 1, it's going to hit the AND gate and return a value of 1. However, because of the inversion bubble, we are going to get a 0. Now, that's all I have to say about that as far as truth gates are concerned. And another thing I want you guys to walk away with today is that the NAND gate is not associative. Okay, it is not associative. However, it is commutative. Okay, so that is what I want to let you guys know today. If you guys like this video, please don't forget to hit that like button. It really helps me out. And don't forget to comment and subscribe, and I will see you guys in the next video.